Michael O'Neill, but most people just call me Irish. I am a principal infrastructure software engineer at BoomTown, which is a real estate software company based in Charleston, South Carolina, with a mission of making real estate agents successful. If you'd like to get in touch with me after this presentation, you can find me on Twitter, LinkedIn, email me, whatever. I love nerding out about this kind of stuff, and will talk your ear off. So let's get to it. So obviously, the best way to start a presentation on cybersecurity is to tell the audience that I am not an expert and that they shouldn't listen to me. So, more specifically, I want you all to understand that this is not a lecture on how to secure your systems from any and all attacks. This is not a guarantee that you can follow these 6 simple steps and never have to worry about security again. This is not a big sign that says, I'll be responsible for your security issues in the future. What this is a story about how BoomTown started using HAProxy's Web Application Firewall, the lessons we learned along the way, and some things for you to consider if you want to start using it yourself. Because even though I'm not offering you a complete and perfect solution, it helps. But I don't have to be a security expert. I don't have to solve security problems by myself. Everything I really want to do has already been done by actual experts. Solving those problems is what makes them experts. By using the tools they've made available to the rest of us, I was still able to improve our security posture. And there were also several positive knock-on effects as a result of what we did, which we'll get to later. More importantly, while our particular tech stack and configuration may not perfectly match yours, it's probably not so unique that you'll have trouble finding something you can mimic. Now, the marketing people I work with probably won't be happy about this, but for the purposes of the presentation, what BoomTown does isn't especially important. But for a little bit of context, it's okay. It's totally okay, thank you. Breaks the tension for me. Yeah, I get you. So for just a little bit of context, though, our customers are realtors. Their customers are people looking to buy or sell real estate, who we call consumers. The important thing for you all to know is that we provide the realtors with a website where consumers can browse and compare real estate, get in touch with the realtors, schedule viewings, that sort of thing. The larger point is that every one of our customers has at least one website that we host, which means we have thousands of sites to concern ourselves with, and all of those reside comfortably behind HAProxy and now its Web Application Firewall. So before we go any further, I'd like to take a moment to establish a bit of a baseline understanding of firewalls as well. Now, you're all a bunch of smart IT professionals attending a conference hosted by a company that builds networking products. I think it's safe to assume you have a pretty decent understanding of what firewalls are and what they do. However, like any topic in our field, this can get about as deep and complex as you're really willing to investigate. So for a quick overview, we're only going to concern ourselves with 2 types of firewalls and how they've been used to improve our security posture at BoomTown. A basic firewall essentially allows you to define whether traffic to or from a particular port or IP address should be allowed or denied. They typically use static rules that you set and forget. A basic firewall allows you to push some of the security concerns to a lower layer of the OSI model, so you don't have to spend time thinking about authentication and authorization methods for certain parts of your application that only a handful of hosts on your private subnets can even reach. Most of the time, this type of network control is sufficient to mitigate a great deal of risk. And these rules are useful, but they are a bit crude. For example, what if somebody gains access to something within your private network? The exceptions you wrote for your own hosts are now a vulnerability. As the name suggests, web application firewalls are specifically designed for web applications. They look for known attack patterns and vulnerabilities to protect systems from... I'm going back. We're not skipping the rest of it. I lied. Sorry, everybody. What if somebody exploits another system within your network? Great. So this gets even more complicated when you want to have a public-facing application that everyone in the world should be able to access, but you also want to reserve the ability to kick them out if they start causing trouble. In the past, when we started seeing concerning performance metrics, we'd have to look around the system, check if anybody had released anything recently, if the services we were calling were having problems, or if the problem was widespread, if it was just a particular user, that sort of thing. But neither us nor the firewall really knows if we're dealing with a performance issue because of our code or because of a targeted attack. Eventually, we might find that one particular IP address was making hundreds of requests per minute, and we could begin the process of logging into our own firewall manager, blocking that IP address if we were comfortable blocking it in the first place. We might be okay blocking IPs from data centers outside of our country, but maybe not so much a residential IP where we do business. If we do block an IP, when do we choose to unblock it? There are a lot of problems that we can't solve with a purely static set of rules. So this isn't good enough. So what does the Web Application Firewall bring us instead? As the name suggests, web application firewalls are specifically designed for web applications. They look for known attack patterns and vulnerabilities to protect systems from the reality that modern web applications face. That is, somebody's always trying to break something. They can also look for atypical requests because there's always a new attack method. Our particular solution, the core rule set from the Open Web Application Security Project, or OWASP, even came with rules for WordPress, which is what the consumer sites actually run. This type of firewall is primarily concerned with the behavior of the client and the server. Its rules are far more dynamic and robust than simple checks for ports and IP ranges. They're able to inspect the request a client makes to determine whether to send the request to the server or just drop it. They can even look at the response the server would send back to the client to determine if you might be leaking information, and then choose to drop that as well. Can you scroll? Thank you. I realize they're doing it, not me. So automatically blocking and unblocking clients based on their behavior or requests based on their content allows for much greater flexibility in your security than the static rules of the basic firewall. Now, security is both important and frequently neglected. Maybe you don't store especially important information. Maybe you consider yourself a low-value target. Maybe your product and marketing people think it's more important to get new features out the door than spend time on security. Maybe your proof of concept went into production despite your concerns and warnings. Whatever the reason, it can be difficult to actually get the time to work on security issues. Unless, of course, it's too late to do anything about it and you're in damage control mode. BoomTown doesn't store any personally identifiable information, payment information, or anything like that. Still, we don't want anybody in our systems or messing with things, and neither do you. So just how important is security really? How do you make the case that you should be given the time to work on it for people who only care about the bottom line? According to statistics provided by IBM, the average data breach in 2021 cost $4.24 million. Then there's the $1.59 million on lost business opportunities on top of that. The average cost of a mega breach, so 50 to 65 million records, was a staggering $401 million. It typically takes 287 days to identify a breach and another 80 days to contain it. 39% of the costs incurred by such breaches occur more than a year later. So these incidents can hurt for a really long time. Symantec tells us that an average of 4,800 websites are compromised each month by form jacking. If you happen to be one of those unlucky targets, you're going to be spending some time and money on it one way or the other. My advice, spend the time and money before it happens. It's worth it. It's also worth noting that if you're paying for HAProxy Enterprise Edition, you already have access to their WAF modules. You're already paying for security tooling, so use it. So aside from the obvious financial motivations, how else can a tool like the WAF help you? At a high level, I'd say the most appealing things we were able to get from it were simple security improvements, load reduction, and a better signal-to-noise ratio in our logs. We resolved entire classes of security issues uncovered by our external security team without actually having to write any new application code. We saw a reduced load on our application servers because malicious requests were simply dropped by HAProxy instead of being routed to and handled by those applications. We even improved the signal-to-noise ratio in our application logs because things like SQL injection attempts and people trying to access files we were going to deny access to anyway no longer make it to the web server to be logged in the first place. Speaking of SQL injection, I hope you're all familiar with the webcomic XKCD. Little Bobby Tables from number 327 really hit home for me and the string delimiter in my own last name. We all know that you can't just let random people from the internet type things and then toss that user input directly into your database. It's just asking for trouble. So what do we do instead? We try to make ourselves feel safe by using a bunch of different input sanitization methods. This list includes just a few of the things well-meaning developers have done to my last name. It's not great. Sometimes they get it right. Awesome. But I've also seen things like replacing the apostrophe with a space, removing the apostrophe altogether, dropping the capital N, adding a slash or 2 or 3, replacing the apostrophe with HTML entity codes, even just rejecting my name outright, which, rude. I understand, though. People are worried that the apostrophe in my last name is an attempt to gain access to their database, so they try to replace it, remove it, escape it, or reject it. This may protect their database, but it harms their data and probably their conversion rates. If your website can't properly handle my name, probably don't want to do business with you because I don't trust you to have made good decisions about the rest of your security. And I'm sure I'm not the only one who feels that way. It also leads to scenarios where people with names like mine have to complete a form multiple times or get form letters addressed to Mr. O and a host of other annoyances. Fun fact, that ampersand 39 example, that was from Google. So even the big guys get this wrong. So what's going on here? How do so many developers screw it up in so many different ways? The simple answer is that they're also not security experts. These issues may annoy me, these developers may have screwed up, but they're all trying to be responsible. They're all trying to do the right thing. They know they need to protect their database from the internet at large, but they don't really know how to. And that's okay. They don't have to. Other people have already figured this out, and the HAProxy WAF and the OWASP CRS will let us use their solutions. The correct way to solve this problem is to use prepared statements and parameterized queries. Cool. How much time would it take you to rewrite every single database query in your application? Alternatively, you could use a single configuration change to add the SQL injection rules to the HAProxy WAF. This would cover every request that passes through HAProxy immediately. Even if it's not perfect, the return on investment with this approach is enormous. Should you still rewrite those database queries? Probably, yeah. But it's no longer a critical issue. You're in a much better position to take your time making those changes without having to worry so much about ending up on the news. So I beg you, please, test your applications with names like mine. If you can properly handle mine, probably in pretty good shape. Now, I've mentioned the OWASP CRS a few times, but let me drive this point home. The Open Web Application Security Project, OWASP, provides an open source core rule set, the CRS. If you are familiar with Apache's mod security tooling, it's basically that. These rules are written and reviewed by security professionals and allow you to essentially pick which protections and exceptions you need from a well-curated list of options. The rules can operate at different levels of paranoia or strictness and can be modified or disabled at levels as broad as an IP range or as narrowly focused as a single argument to an endpoint. HAProxy provides instructions and scripts to help you download and install these rules. There's even an official HAProxy blog post talking about this stuff. It's conveniently titled The HAProxy Enterprise WAF, if you want to check it out later. They also provide some really nice tools to test with. And from the things we heard earlier today about fusion in the WAF, sounds like we're getting even more cool options. Now, I'm not going to go over everything on the core rule set, but this is a list of things that we were interested in for the consumer sites. In fact, we got access to so many options, I didn't really know where to start. DOS protection, SQL injection, scanner detection, and cross-site scripting attack detection were among the most interesting to me based on what I've seen over the past few years, but still difficult to know exactly where to focus. But I'm an engineer, I tell myself. I make decisions based on data, as long as it's not too much of a hassle. Fortunately, there's a detection-only mode that identifies and logs requests and responses which would be blocked if the WAF were fully enabled. This gives us the ability to collect data and experiment in a low-risk manner, which is generally my preferred method. Now, I've spoken before about how a team can build confidence in changes they intend to put into production by knowing the results beforehand and carefully managing traffic with well-thought-out load balancing decisions. To this end, I figured the best possible thing we could do would be to simulate or replay requests we've gotten in the past against the duplicate staging cluster. Unfortunately, I don't have a useful record of previous requests to give to a traffic simulator. I have application logs, but they need a fair bit of transformation. I also don't have a traffic simulator or a duplicate of the production environment to respond to all those requests if I could make them, or a duplicate of the other systems that we interact with. The whole thing became kind of its own problem. So while we don't actually have a good way to simulate production loads at the moment, and we certainly don't have a good way to simulate the various attacks we encounter every day, I do have an environment that mirrors production perfectly. I call that environment production. As previously mentioned, the WAF has a detection-only mode. This allows us to do a bit of a dry run in production without much risk. Still, this can be a scary thing to do. If you want to do something like this, tell your support team. I'm sure you have a process, you need approval from other engineers and management and so on. Great, do that. But make sure you also tell your support team, even if it really is safer than it feels. Tell them what you're going to do, what to expect if anything goes wrong, and how to let you know about it right away so that you can roll back your config changes really quickly if there is a problem. The WAF is very fast, but it will put some extra CPU load on your HAProxy host, so be aware of that as well. I told support what they might expect to hear from a customer if I screwed anything up and what to do about it, namely, message me. Configured the rules, turned it on, and started tailing the logs to see what kind of nefarious deeds we were being subjected to. Then I stopped tailing the logs about half a second later because I couldn't keep up with the output. At the time, the consumer sites actually got more than 2 million unique visitors per day. Small amount of traffic for some of you, a lot of traffic for some of you, a lot of text for anybody with a human brain for reading stuff. So our throughput pretty much never drops below 6,000 requests per minute, and going as high as about 13,000 requests per minute, not unusual. On a typical day, we might respond to 20 million web requests. So these are just not good logs to tail. Strongly recommend you aggregate your logs and add as much structure to them as you can to make querying and analyzing them a bit more approachable. Baptiste actually spoke the other day about JSON logging in HAProxy. If you can get those slides from him where he has an example, do that, because that looks amazing. Our consumer sites run WordPress, which is one of the most popular web platforms in the world, and is a bit of a victim of its own success when it comes to people looking for security vulnerabilities on public websites. Between my underestimating just how many people were looking for such vulnerabilities, and the number of false positives, there was just too much data to dig through in those logs to determine which rules were working well, which needed to be further tuned, and ultimately, what was safe to enable without impacting legitimate users. So, as with any good experiment, you really need to consider your controls and variables to avoid confounding your data. The most common way for us to know anything bad was happening on our sites at all was when performance tanked, and we noticed a huge uptick in the request rate, generally from a very small number of IP addresses, and also generally coming from countries in which we don't operate. So the new plan was to disable everything but the DOS protection rules. We'd leave the WAF in detection-only mode. I even set up a special log file just for WAF output to avoid overwhelming myself again. After we had some more useful data, I could investigate who we would be blocking to see if any patterns emerged on that front and determine appropriate request rate limits. It's worth noting here that the default rate limits consider 100 requests per minute per IP a burst, and blocks an IP for 10 minutes after its second burst. You can tune this, but that's the starting point. Is there more on this? No. Thank you. So we let this experiment run over a weekend. With a bit of shell scripting, I was able to turn our giant collection of logs into a list of nearly 21,000 unique IP addresses we would have blocked. I was eager to find the worst offenders and see if we could go ahead and permanently block some of them with our traditional firewall. And the results of my analysis were illuminating. The top 5 most common IP ranges in our logs, that is to say, the first few systems that we would block, were the WordPress hosts themselves, the BoomTown Office, the BoomTown VPN, Google, and Bing. Obviously, we don't want to block ourselves or search engine crawlers. This was not a useful block list. Clearly, I'd screwed something up. Fortunately, no customer impacts yet. So this is the part where you all get to learn from my mistakes. These are also the only configuration file snippets I'm going to make you look at. Can you guys see that okay? The WAF operates as a filter that can be applied to an HAProxy listener, front end, or back end. I added this filter to the front end, listening on ports 80 and 443, because obviously I want to check all incoming requests. We run several services behind this HAProxy front end, including one that gets data to populate the consumer sites. So every time somebody visits one of our sites, they make one request through HAProxy. But the WordPress host sends several more requests through that same front end. Remember when I said we were getting requests, 6,000 to 13,000 requests per minute from consumers? Well, those requests are spread out across each user's IP address. So they're pretty unlikely to hit 100 requests per minute. But we don't have nearly as many WordPress hosts as we do users. So we're able to rack up 100 requests per IP in just a few seconds. Everyone in our office is also accessing our services from the same public IP address, so the WAF sees all of them as the same user. And with a few hundred people in the office using our services and developers on the VPN doing the same thing, it's easy to see how we could block our own servers and employees pretty quickly. There are several ways to address this issue, but the quick and easy fix was to write a rule that allows all traffic from private IPs, the Office IP, and the VPN server to effectively bypass the WAF. This, of course, makes it difficult to test other rules, so this is not a full long-term solution. But by refining this exception just a little further and disabling just the DOS protection rules for these IP addresses, you can stop blocking yourself from making too many requests, but still make sure that your internal host can't be directly used to propagate an attack against other parts of your network. The other big change we made was to apply our filter to the back end we were trying to secure rather than the front end. We have more backends than front ends, and our backends are built with a bunch of different technologies. Adding WordPress exceptions and PHP rules isn't going to do much for our C#.NET services. And by applying the filter to the backend, you can use different configurations for different technologies with those different concerns. So spend some time thinking about the similarities and differences between your different services and their particular security needs. So I now had a good solution to prevent us from blocking ourselves, but I didn't yet have a good answer for search engine crawlers or other large office buildings. The DOS protection rules were just too blunt an instrument for us to start with. So I tried something different. The new plan was to stick with detection-only mode. Clearly, we're not ready to block people yet. We would apply the WAF filter only to the consumer site's backend. We'll disable the DOS protection rules, enable everything else one at a time. Don't break anything. It's detection-only mode. It's fine. No reason to be nervous. So these rules didn't generate nearly as much log output. So monitoring behavioral changes was a much more reasonable undertaking. The more we investigated the hosts and requests that the WAF said it would block, the more confident we started feeling that we were no longer getting false positives. So we put the WAF into enforcement mode. Despite my confidence, I spent the next 10 minutes staring at the throughput line in New Relic on one monitor and watching the WAF logs on another, just waiting for something to go horribly wrong. But nothing did. This is where I once again remind everyone that sometimes we really do have to test things in production. But if we're patient with our data collection, deliberate about the design, and ready to roll back, we can do so pretty safely. On that note, big shout out to my coworker Sterling for making sure that I was patient and deliberate with this. The WAF has been running well since May, and a lot of requests that used to get through our WordPress hosts, maybe even down to some of our internal APIs, no longer make it past HAProxy. Our external security team confirmed that this resolved several potential issues they found when testing our sites previously. This is good news all around. In June, we were lucky enough to get hit by a few more high-volume bursts from a single user agent we'd never seen before and just a couple of IP addresses. With better logging and such a specific thing to look for, we were able to much more easily compare performance-impacting request rates with our more typical request rates. We decided we could be more lenient in some ways, but should probably be more strict in others. We actually increased the burst criteria from 100 requests per minute up to a more generous value, but we also increased the block timeout from 10 minutes to something a bit more aggressive. Sorry for being vague on this point, but while security by obscurity isn't exactly a best practice, neither is telling people exactly what you're looking for. What I can very comfortably say is that we've had significantly fewer performance-impacting events caused by targeted attacks in the past few months than at any other point in my tenure. So, not bad for amateurs. So, what did all this really get us? Peace of mind, mostly. But it also saves the tech ops team from playing IP whack-a-mole, and we have a few interesting numbers to go with it. I struggled with a sensible way to display this data, so please bear with me. After enabling the WAF, our average throughput, or total requests per minute, dropped pretty significantly, roughly 34%. The number of 404s we returned per minute dropped by about 30%, or approximately 200,000 per day. Largely due to HAProxy determining that these requests were up to no good from the start and terminating the connection entirely rather than waiting for a WordPress host to discover that it didn't actually have the requested file. Unsurprisingly, the largest drop we saw was in 403s. A nearly 77% reduction in 403 responses meant that we were barely even getting to my own special rules for files to deny access to. The WAF has a pretty good idea about what people shouldn't be allowed to do. The really nice thing here is that there's no statistically significant difference in the number of 200 OK responses, sitting right there at 50% before and after. I had still some concerns about false positives, and these numbers largely alleviate that worry. However, I must admit, we have gotten a few support tickets from customers having problems making certain changes to their sites since first pulling these numbers. But we were able to resolve them pretty quickly, and we're talking less than 1 ticket per month. Certainly, they're less painful dealing with a major security incident. Overall, our sites are more secure, our logs are cleaner, and our servers are doing less junk work for bad actors. I call it a win. We have time? Thank you.
Thank you, Irish. Wonderful job. So we do have just time for maybe 1 or 2 questions. So again, raise your hand high if you have a question in the audience, and we'll come around to you. So there's one over here. We're waiting for that. There's a rock climber fan also in the chat.
Right on.
What would you say is the biggest software engineering problem you had to solve, and what has been your biggest rock climbing challenge, and which one was harder?
So, toughest software engineering problem is probably one I'm working on right now. We're trying to do, I don't know how much I can say. We're trying to move one service between providers with, as you know, 0 downtime, because that's my whole jam. Fortunately, my buddy Anthony on my team is doing a lot of excellent work there with me. So I think we'll get that, but still, it's a months-long process. Hardest rock climbing thing I've ever had to do was basically my first inverted route where I actually was climbing upside down, had to traverse distance upside down, which very physically demanding, kind of scary, but still it took an hour to like figure out and get the hang of that bouldering route. So months long versus an hour, I'd just rather do the rock climbing. It's
easy win.
Yeah.
Thank you for your presentation. I don't know if it was the same question, but for your version 2 experiment, how long did it take you and your team to establish for the WAF all the rule set that you needed? Instead of staying in report mode how long did it take to switch to block mode?
Yeah. So is it just asking how long were we in detection-only mode versus until we switched over to enforcement mode? A couple of weeks. I really only ran like the big experiments, like over a weekend, looking at it a couple of days at a time. There was no real rush. It was a thing that we wanted to do. We thought it would be better. So we kind of took our time with it and just made sure that we really had everything that our logs indicated to us that we were making a good decision. But yeah, maybe a month total.
Okay, that's all the time we have for Q&A. Irish, thank you so much. Again, big round of applause.
Appreciate it.
Great job.